Hello guys, I will react to this. Google is quietly revolutionizing AI agents. A video of Cole Medin.
Introduced their agent to agent protocol, which is a standard for agents to communicate effectively with each other. It's very similar to how MCP is the standard to connect agents to tools. In fact, you could call MCP an agent to tool protocol. And just like MCP, A2A is very revolutionary and not getting the attention that it deserves with its initial launch. Plus, both are very complementary. More on that later. MCP did not blow up right away. It took time for people to realize its true power. But just look at the interest over time compared to other technologies like DeepSeek and Manus. It's
How we compare MCP with DeepSeek? How it's comparable? I don't get it.
clear that MCP was never a hype train and that people just gradually realize over time that it's the real deal. And A2A was released very recently, but it's already looking like it's going to follow a similar path. And it makes sense. For more technical protocols, it takes time for people to grasp them and for the creators to perfect and simplify things enough for wide adoption. That's what's happening with A2A, and it is going to be a big deal. So right now, let's cover what A2A is and what makes it so powerful. It's worth investing the time to learn this now, because this is the future of AI agents and how they're going to communicate with each other. Plus, I do have some concerns with A2A and other protocols like MCP, so I'll cover that at the end of this video. It's definitely worth talking about that. But for now, let's get right into A2A. So the first thing that I want to show you is the announcement post from Google introducing A2A. It's very short and sweet, just introducing the protocol at a high level. And the thing that stands out to me the most is the number of partners that they already have on board with A2A. Salesforce.
What? On board. What it means on board? They just introduce a thing and then they have 5 roles of.
Accenture, MongoDB, Neo4j, Oracle, LangChain, so many companies, a lot of these AI specific. It's really cool to see them all on board. There's a lot of stock behind A2A already, one of the big reasons that I think it certainly has legs. And most of this article is just a bunch of testimonies from their partners, which is cool to see, but it also means that we don't really get that many details for A2A. It's super high level and kind of vague, honestly. I mean, a lot of people don't even know what interoperability.
But what? What is this document actually? I, it's not describing a standard. This is just an announcement.
Is. And so a lot of this reminds me of the article that we first got from.
Yeah, but it's not because it's.
Anthropic introducing the Model Context Protocol. This was given November 25th of 2025, but we all know that MCP didn't really blow up until maybe around March of 2025. And so clearly a lot of people read this higher level kind of vague article similar to A2A, and they just completely glossed over it. It wasn't until we had the official documentation from MCP and things were explained in more layman terms, like it's the USB-C port for AI applications, that people really started to latch onto the concept of the MCP protocol overall. And honestly, I think I should have covered MCP a lot earlier on my channel. I know that people like you trust me with your time to keep you up to date with the latest AI technologies and how to leverage them effectively. And I feel like I dropped the ball with MCP. I covered it way later than I should have. And so right now with A2A, I'm making sure that I don't miss out on that. This is a very important technology and there's still a lot to be developed out for it, but I want to introduce you to it now because it is a game changer. So to help you understand the true power of A2A, I want to give you a crash course really quick here with a theoretical example, and then I've got a bunch of benefits of A2A listed on the right hand side. So I'm not going to dive into all of these in detail. You can read these here if you're curious. But there are a couple that I want to focus on. But first, let me explain this example. So something that is very common with agent architecture in general is to have many specialized agents that are all working together. And the reason for that is just think of humans working together. It's always beneficial to distribute responsibility between many people so they can all be very focused. And the same thing applies.
Okay, but uh, MCP is not model specific, it's not vendor specific, it's not tool specific. And here, what makes the A2A object of this video not model specific or vendor specific or tool specific.
Is two agents. And so like in this example, we have a sales agent that can interact with CRM tools to do something in your CRM, maybe HubSpot or Salesforce, go high level, whatever that might be. And that is through MCP. More on that later, but yeah, this also kind of shows you a little sneak peek of how we can use MCP and A2A together. But that's our sales agent. But then it can also call into these other specialized agents like our data analytics agent or finance agent when the question from the user would require one of these agents more than the sales agent itself. And this kind of communication has always been available to us. I mean, similar to MCP, where we've always been able to give tools to our agents before MCP, we've always been able to connect agents together before we had A2A. But A2A just makes the entire process more accessible and standardized, and that's very powerful for quite a few reasons. The first one is that we can have these agents all built in completely different ways. Like maybe our sales agent is built with LangGraph, and then our finance agent is built without a framework at all, and then our data analytics agent is built with Crew AI. They can be hosted in different parts of the cloud from different vendors. As long as they're all following the A2A protocol, they can communicate with each other seamlessly, and we don't have that kind of flexibility without a protocol like A2A. And then the other benefit that I want to focus on right now out of all of these in this list is think about what we have without A2A. Usually when we connect agents together, we take the functionality of the finance agent and then we program some sort of integration into the sales agent to leverage that. But the problem with that is we have to know ahead of time within the sales agent how we interact with the finance agent and what it is capable of doing. So as soon as we update this agent, we are at a very high risk of completely breaking the integration of the finance agent within the sales agent. And that is a problem. We need something much more dynamic, and that is what A2A gives us. It gives us the concept of agent discovery, where the sales agent in real time can learn what the finance agent is capable of and how to interact with it so that it can make that determination at runtime. And so then when we update the finance agent, we have much less of a risk of breaking the integration with the sales agent because everything is just much more dynamic. So those are the two big things to hit on, but there really is a big list here. And we'll dive into a lot more of these things throughout the video. But I hope that this can just help you see at a high level the insane amount of benefits of using a protocol like A2A. Next up, we have the GitHub repository for A2A. This is where you can really start to dive into the details behind this protocol. And since this is a GitHub repo, we know that A2A is 100% open source, which is crucial for any protocol to be widely adopted at all. So already a win here. And then scrolling down in the README, we get to the conceptual overview where we can start to dive into all the different components for the A2A architecture. And so as we know, it's a protocol for agents to communicate with other agents. And the first big component to that is we need a way for agents to know what they can do with other agents. And we do that through what's called an agent card. And honestly, this is a long time coming. I'm surprised that there hasn't been another protocol that's implemented something like this. It's so powerful to have this way for an agent to describe its capabilities, how to interact with it, any kind of authentication requirements to other agents so they know how to work with each other, all through a single metadata file. Very, very powerful. And the way that agents communicate with each other, and the agent card is a part of this, is we have agents that run as servers and as clients. And so this is very similar to a microservice architecture, if you're familiar with that. You just have all these agents that are running as API endpoints They're each individual nodes that are all connected to each other, and they use the agent cards to understand how to interact with each other. And so your agents that are running on servers, it's just an HTTP endpoint that's exposed for other agents or other users. Like you can have an application if you want to interact directly with an agent as well. And then the clients, it's just you or another agent, and you just consume an A2A service, as in you call into one of these servers. And the way that you do that is with tasks. And so you generate an identifier for your task that has your request to the agent, and you know what kind of requests you can make based on the agent card. And then you just send that into the agent server. So you have your message, any other components to your request, and then you just get a response back. It's very simple, very similar to just standard API operations. And there's support for push notifications. So you can have your agents that are running in servers update the other agent clients in real time, which is one of the more technical, but also one of the more powerful parts to this protocol. And then that brings us into what a typical flow looks like for agents to interact with each other. But to make this crystal clear for you, I took this text and some other stuff from their documentation and I distilled it into a couple of beautiful diagrams that I want to share with you now. So with all the concepts explained from the GitHub repo, I hope this diagram makes a lot of sense to you. So we start with our client agent, and it's of course going to start by fetching the agent card from the A2A server, which is our other agent that we're communicating with. It'll return the agent card, so we now know what we can do with this second agent. And so first we'll generate a task ID. This is just a unique identifier for the request that we're about to make. And then we'll send that ID in along with the JSON payload for the request that we want to make. So knowing what we can do from the agent card, we'll form some sort of request. Like we maybe wanted to send an email or summarize some text, whatever this agent is capable of. And then that agent will process the task and then return the results of executing that task along with some other metadata, like if the request was successful or not. And that's it. That's A2A at a very basic level. It's not that complex overall. It certainly feels complicated when you try to really dive into the GitHub repo, but really this is just an architecture. And that's the other really important thing to clarify with A2A. It is not a tool that you download. You don't pip install it like you would with LangChain or CrewAI or Pydantic AI. It's just a high-level architecture, and all the code in the GitHub repo is just examples for how you can build agents in a way that fits with the A2A protocol. And that also means that it's a more important skill to learn in general. Like when you learn from A2A how to build agents that communicate with each other effectively, you can apply that to your own architecture that you would make, or you could build on top of A2A. It doesn't matter if A2A goes anywhere, because anything in the end that standardizes the way that agents communicate with each other, it's going to look very similar to A2A. And then I already alluded to this at the start of the video, but you can use MCP and A2A together. They are very complementary to each other, and the reason for that is they operate on different layers of the agent architecture, because MCP is agents to tools, right? And then A2A is agent to agent. And this diagram shows you very clearly what that looks like. So we have our client agent that's running on the left-hand side. This uses the A2A protocol to call into some other agent that we have running as an A2A server. And this second agent that's running in the server, maybe it's using the Brave MCP server to give the tools for it to search the web. And so we have a web search request that comes in from the first agent that goes into our second one, which then uses the Brave API through MCP to search the web and get some results back from the web search. And then our server agent will reason about that, craft that final response to fulfill the task that our client initially gave. And so we're using A2A at the higher level to call into one agent, and then that one agent is using MCP for its tools. Side note really quick, I don't know if you realize this, but with A2A and MCP, we have our entire backend built out. We have our servers and agents with A2A, and then we have the tools for our agents with MCP. The only thing we're missing for a full AI application here is the front end to wrap around everything that we've got going on with A2A and MCP. So we
And another thing which is interesting is that the agent 2 and 2 API from this diagram kind of seems to be on one machine, on a separate machine, or I don't know, this is very high level, like there is no specific here.
We just need a standard, a way to easily create our front ends as well. And I have you covered for that because we have Lovable. This is my solution to build out almost all of my front end applications for everything that I'm doing with AI. And they are sponsoring this video, but I reached out to them specifically for this because it is my genuine recommendation. And I'll even show you that I used it to build out my landing page for Dynamis, which is my AI early adopter community that I've started. Obviously, I care about making this website perfect, and I chose Lovable to do that. And if you look at my conversation, just look at how long this is with all of the work that I put into perfecting this landing page. And Lovable handles it all, and it handles it very, very gracefully. And so it doesn't matter if you're a developer looking to code faster, you're an entrepreneur that doesn't have the technical know-how, but you have all these good ideas that you want to build out, or you're a designer that wants to take your designs in things like Figma and turn it to life with a full website. You can do it all with Lovable. And that really is the last component to combine with things like MCP and A2A to build an end-to-end AI application. It's a great thing. So I always love to give very
What it means end-to-end AI application? End-to-end application with AI components. Let's see.
concrete examples when I cover anything on my channel, and obviously with A2A, it's no exception. And so what I've done here in Python, I've created a very basic implementation of a server and client following everything with the A2A protocol. I'm not importing anything from A2A because it's, again, not a tool, it's an architecture. So I'm just building everything out, following all the practices laid out in the GitHub repository. And this is a very basic implementation because I want to cover the core concepts that are important. It's much simpler than anything you'll find in the GitHub. So look at those examples if you want a full implementation. But if you want to just understand the important parts, I've got you covered with this, including how you can use MCP within the A2A agent servers. So a lot of value packed in right here. So the first thing that I'm doing is just defining my Brave MCP server with the Pydantic AI integration. I don't want to dive into Pydantic AI here, but that's just the framework I'm using to build this agent. And then I just added as an MCP server to my agent definition. So now my Pydantic AI agent can use the Brave MCP server to search the web. Nice and simple. And then the next thing is I need to define my agent card. And so I just followed the specifications on GitHub for this, a very basic card where I'm just giving the name, description, how to reach this agent, its version, and then describing its capabilities at a very high level, not really giving it any because I want it to be simple. But yeah, this is a very basic agent card. And then in the standard endpoint, we give the ability for other agents to call this to fetch the agent card and know what this agent can do. Again, everything that we've already covered within those diagrams. And then the other endpoint that we have is the one to handle all of the tasks. And so any client is going to call this endpoint and then generate a task and call this endpoint. So we fetch the ID of the task, also the user text. This is basically just the text for the request. And then we call our Pydantic AI agent to handle that. And it can use Brave to search the web if the user is requesting something that would elicit that. And then we just get the response from invoking our agent. And we build up this JSON body, which represents what we're going to return as a response to the task request, just saying that the task was completed successfully, and then passing in the results of calling that agent. It's very nice and simple. And then we just have this as an API endpoint running on port 5000. So overall, it's a pretty standard API implementation, just with a couple of things that are specific to what we need for the A2A protocol, like the agent card, and then the specific endpoint to handle task requests that are coming in. But it is very similar to just a standard AI agent that's running behind an API endpoint. And then for my client, I just wanted to make this as simple as possible for this demo. And so I show you what it looks like to fetch the agent card. I don't actually use that to figure out which kind of task I can run, so I'm just hard coding this here. But this is how you can just fetch the agent card, just hitting the agent.json endpoint. And then to build up a task request, we just generate an ID like this, and then we build up our payload. So just like we have a JSON response for the task, we also have JSON for the input. So we have our ID, And then we have our messages, which we're just sending in the request from the user, which in this case, I just have a very basic question. What is Google A2A? Which is the kind of thing that an LLM wouldn't know because of its training cutoff. And so it will have to use the Brave MCP server to answer this question, to fulfill my task request. And so I build up the task payload, and then I just send it in like this. Really nice and simple, very typical API stuff. And then I just handle any errors that might come up. And then if we have a success, which we're always going to get from this server because it's a very simple implementation, just always returning completed. But as long as it's completed, then we'll print out the agent's reply. And so the way that this works in my terminal is in one tab, I have this server running. So I just ran python server.py. We've got the server running on port 5000. And then in my other tab, this is where I'll run my client. And so the command is very simply python client.py. And so this is going to take that question, what is Google A2A? It's going to generate a task ID and then send that task into my API endpoint. You can see that we got that first request to get the agent card. And then once it processes, yep, there we go. We got the final result from sending in the task as well. And then back in our client, we can see that we got a response for what Google A2A is. All right, it's for agent interoperability. I'm trying my best to say that word correctly. And yeah, we see that it's got support from partners, a lot of these things that it's pulling from, yeah, the Google developer blog. It's clearly using Brave to get this response. And so there we go. That's A2A in a very basic sense, also leveraging MCP for the tooling. So I know at this point, I've only been focusing on the positives for these protocols, and for good reason. They're super powerful, and they definitely have a bright
But
future. But they're
what is the protocol? I didn't get it. The ID, the the status thingy. What? I mean, where is the protocol? The protocol is saying that we need to have structured uh, communication between two machines. But that's kind of obvious, isn't it?
also a lot of issues and concerns that I have with them that I certainly owe to explain to you right now. There's a lot of work that has to go on to really make it so that these protocols are production ready and that they're ready for wide adoption. And so it's going to be doom and gloom for a couple of minutes, so just bear with me on this, but then I'll lighten it up at the end because there certainly are solutions to all of the problems that we have here. So the first big problem is testing complexity. Just think about this. If you're building an agent all in one code base, you're not using MCP and A2A, everything's nice and simple. It's in one place. It's going to be very easy, at least relatively, to build out your unit testing, your integration testing, just make sure everything is reliable. But when you have all of these nodes running in the cloud or wherever for your different A2A servers and MCP tools, it becomes a lot more complex. And if you're familiar with microservices, you know about
all these nodes and ports which are listening for somebody to ping them, they should have their own testing functionalities. So breaking down the testing, I mean, there is no, I cannot foresee any problem if you break down the a big task to smaller tasks. And if you want to test the task with different inputs, for example, expect different outputs. The smaller the task, the better the test. Like
edge case explosions where there's just so many different
edge case explosion. Edge case explosion is the thing. Yeah, the more structured outputs and inputs, the more, the less edge cases, the better the actual model following instruction, the better task execution with less edge case. It really depends on the underlying model which will be used to execute tasks. I guess Google are simply putting a lot of effort into Gemini 2.5 Pro to really follow instructions. And yeah, in my opinion, this would be the primary performance metric for an LLM model in the future, following instructions. And how, and in this case, edge case, lack of edge case, lack of hallucinations. Hallucinations are a result of an edge case.
Different nodes where you can have problems now, and it's really hard when you encounter these issues to also reproduce them because there's just so many components to your system now. And you have to add in the fact that all of these different nodes are relying on LLMs now, and they're also not predictable. And so you might run into a problem that's just caused because an LLM hallucinated. And so maybe you don't have to worry about it, but also it's always going to be on the back of your mind that this thing failed once because of the LLM. Who knows if it's going to happen again? It can be very stressful and hard to engineer well for these challenges. And then we also have security concerns because when you have all of these nodes for your servers and your tools, there's just an increased surface area for any kind of cybersecurity attack. And with these protocols, the dream is to have it so other people can build these MCP servers or A2A servers that you leverage. But that also means that you're just sending all of your data into more third parties. So it's not just going.
No, again, why third party? The idea is that you need to be able to build a backend which is connected to LLMs for a certain functionality. Like, yeah, there are security concerns and data privacy issues, but here we are not. I don't think actually we are speaking about um, on agents like if we are speaking about something as the concept of service as a service, but this time agent. For example, if we have like uh, MariaDB database and we have an agent to interact a database, and then we have uh, it's in the cloud, in the MariaDB cloud. It's a service that you pay for, and and we are using the so-called agent-to-agent protocol for your backend to access that service. Yeah, there is increased attack service, data privacy, and authentication challenges, but yet first we need to focus having our backend full of these tools. So, and then we can focus improving the agent functionalities to a proprietary agent. So I think the future of agents is first to be more specific and to more be like agents made by a company X, rather than services bought from a bigger company. So I would imagine uh, this middle rectangle to be the next, the future problems to be solved. And yeah, we have things like OAuth, authentication challenges, authorization challenges, which is not mentioned. We we need to authorize who will do which task and will it be capable of. Also, identity management. All these agents needs to actually manage uh, who is asking, like who is, because they can have tools via MCP which can have big data lakes on the backend, which needs to be accessed in an authorized way. So there needs to be some effort to extend the OAuth and scopes. Not to extend, maybe it's enough. The complexity of OAuth and scopes, uh, it's enough, but to adapt and standardize the implementation of OAuth in the agent to agent, and I don't see that in the document. I mean, I see only high level overview. I don't see uh, something in that document which is saying
To the open
how it will solve this kind of future problems.
API now. It's also going to OpenAI and whoever is hosting that A2A server. And so you have to be even more concerned about all these other people that are touching your data. And there's also a lot of authentication challenges with making sure that that one request that's coming from the agent or the client, whatever it is carried through the entire AI system with all of these sub-agents and tools. There's so much engineering challenge that goes into this. And then you also have hidden complexity. So things become more of a black box when we rely on these protocols because maybe we don't entirely understand how A2A works or we don't know all the code.
How you can say we just defined A to A and now we start not to understand how it works? that I mean, I making a protocol or making something, making a standard for something from certain flow. The idea of doing that is to make it obvious, make it predictable, make it debuggable, error handleable.
Behind MCP. And so we're building solutions around things that we don't understand fully. And so it makes it very hard to debug things sometimes.
We are making solutions based on things we don't.
When they go wrong.
I don't agree. We cannot make things which we don't understand how they work. It's not. Imagine you go to your boss and you say or you start a business and somebody's asking you how you handle security and you say, uh, we don't understand so much, but we handle it. Yeah, it should be adamant how you handle security.
Because it might be just the way that we're interacting with MCP is wrong because we just understand how to work with the protocol incorrectly. So it can be tough. And also when we have these distributed systems, error attribution can be very difficult. If you don't have very good logging and monitoring and tracing set up, it can be impossible to know when one node fails, well, which node is it? In this entire AI system, what actually went wrong? And the accountability can be difficult as well because think about it. If an MCP server fails to use a tool for whatever reason, it might actually be because the agent gave the wrong parameters, not because the tool is actually broken. And so it can be difficult to hold the right node accountable for your entire AI system.
Yeah, but that's the idea. That's the generally the idea of the agent to agent protocol. It should be an error triggered having its uh, life form if the input parameters are wrong or not enough or something is wrong. One of the agents needs to signal the other agent, guy, machine, bro, this is wrong. And then this thing needs to be understood. There should be an internal loop on each agent to try to fix this kind of errors. If it seems fixable, or if it is fixed after the loop somehow, it should retry. Maybe that would be in the agent card. I mean, but all these things should be described. I mean, I don't see them. Why they are not described? Like, also, time. How time is very important here, because all these machines use computing resource, a lot of computing resources, and these computing resources, they take time. And imagine there is some queue in somewhere the bottom of the world where the queue is busy, and all these things I don't see in the so-called protocol. I think it's in the form of an idea. It's not really a protocol at the moment, because there is nothing about time, there is nothing about error, there is nothing about input except some general fields like uh, text input, image input, whatever input. What about kind of interfacing the input? Like in each agent card, so-called, why there is no place for like description of what the input output is expected to be? Yeah, it's a very
So
it's very good, but still on an idea level, in my opinion. Time budgeting. Where is the time budgeting? How we budget time for the agents? How we control the budget? Can we have a dynamic budget based on performance? Shall we think of an algorithm which is calculating a dynamic budget for certain agent? It's giving tasks, but the tasks needs iteration because they have problems. And then shall the client agent try to make the time budget bigger? For example, give me all my documents for the car, and that's the task. And there's some agent which is digging into whatever storage persistence layer there is, and with a default time budget of 10 seconds, the agent is failing to give all the documents. Shall there be an algorithm which is trying to give it 100 seconds, like 10 times more? If it cannot complete the task for 10 seconds on the first try, I mean, there can be an algorithm. And then the upper agent, if he receives like a task, he can have internal breaking down procedure for this task to small tasks. What about that one? Shall there be a recursion there to ask itself for a small task? I mean, shall there be a whooping functionality, like, and then recursive to be able to ask and then form a big response with all the documents? I think some of these things seems logical and sounds logical, and they are not described here. I don't understand, but yeah, we agree that there should be a standardized protocol for LLM to LLM communication, as I see, because agent, everything is like agent. But yeah, okay. Everything that listens on a port is an agent, you know. Let's finish the video. It's a nice video. Good job. But I think there is a lot of uncertainty and ambiguity in this.
So many problems
Still.
with this. And like I said, there are solutions to all of this. Google is working on things for authentication, a lot of these issues, really.
Google is working on things like authentication. We have authentication. We have OAuth. We have scopes. We have systems. We have protocols. We have RFCs, which are already there. They just need to be plugged into the so-called protocol, like described. Guys, we'll use this in this way. For example, the agent can have a method for generating a hash based on a RSA private key, which hash would be the grant for a certain task. For example, imagine personal assistant agent, and then we have a third party data lake behind it with documents like invoices, for example, for the person. And then the person is granting the ability to request from the data lake agent all the invoices for furniture. And this would result a hash, a string. And this string will be given to the third-party agent of an audit company, which will have the possibility to ask the data lake agent with that hash for all the invoices for furniture. But the data lake, I mean the third party will have the grant, but it will not know what 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 is the context. To just know, to just send to the data lake agent this with the request, and that's what I expect in the A2A protocol. Things like this, how we authenticate, how do we authorize things in this case. So the third party will just ask the data lake with the grant, guy, please give me uh, all the information for this grant. Imagine that kind of call. And then the data lake will take the ID of the grant and see what means all the information. It's stateless. So it will actually decrypt. Let's say we are using text. It will decrypt. In the beginning it will encrypt, and then it will decrypt the grant to a plain text permitted content to be shared with every request that consists the grant. But I don't see this kind of. So in this case, the customer agent, the personal assistant agent, um, needs to have um, a task for needs to have the ability to send a task to the data lake agent, like give me a grant for all my invoices for furniture, and then this task, the result of this task shall be the grant encrypted string, might be a tool, a function call, and the personal agent will get that grant eventually successfully and distribute it, which will have a validity like half an hour or 1 hour by default, and some, I mean, configurable, speakable, inputable validity, and to distribute it to a third-party agent. Data privacy. So data privacy can be addressed by like ensuring HTTPS everywhere on these agents and endpoints. It's kind of, I mean, on the moving data level, behind the scenes, what the LLMs, how they treat data, it's more complicated. Error attribution. So every like an error thing, and yeah, then if there are so many, the third party agent will ask the data lake agent, give me all under this grant, all data permitted by this grant, and the data lake might happen to have the functionality to call itself, to whoop, with some protection, of course, to ask itself to break down. Because if imagine if there are 100 uh, uh, invoices about furniture. How much time this should take. And also, when the third party is calling, the third party agent is calling the data lake, there might be a callback, a delay. If the task is big, what's happening there? If the task will take a lot of time, there can be real-time blocking process of algorithm of evaluation. How much time this should take in the data lake agent. And if there are 100 invoices, it might decide to offload the response to a callback. And there should be a general callback. And to respond with an ID for a callback. And every agent to have also callback endpoint. This is not mentioned even how many kind of endpoints it shall have, how many standard things there shall be in each agent. But let's not let our imagination so much, and let's finish the video. It's a nice video. Thank you.
I think Anthropic is working on a lot of these things for MCP. And we know from past engineering problems with things like databases and microservices, like you can solve for edge case explosion. You can solve for being able to debug these systems even when you have so many different components. It's definitely possible. So that's everything that I've got for A2A, and I really think this protocol is going places. Google has done a great job laying out a foundation that just needs to be built out to tackle all these issues that I just went over. But I think that's going to happen. We're going to get to the point, maybe in a year, maybe in 2 years, where we can use these protocols like MCP and A2A to build these AI systems very easily that can scale, that are secure, that can handle all these different requests and be tested easily. There's a lot of work that will need to go into doing that, but I think it's going to happen. So let me know in the comments what you think of A2A. Are you going to use it to build out your own AI agents? I'm curious what you think of everything, the good, the bad, and the ugly. I certainly think it's going to create a new standard for AI agents going forward, but it's going to take a long time for it to be widely adopted, especially because of all of these different issues that Google and other companies are going to have to address. It's definitely going to get there though, and I'll keep covering.
Google have to address. No, we all have to address. We all have to agree first which are the problems, which are the topics, and then we all have to address them, I think.
Covering these protocols as things progress. So if you appreciated this video and you're looking forward to more things AI agents, I would really appreciate a like and a subscribe. And with that, I will see you in the next video.
Yes, very nice video. Like and subscribe. Thank you guys. See you in the next one.